Hi everyone, this is Chris Delion of HobbyGameDev.com, and today I'll be giving a quick crash course in how to use Unity to quickly and easily make small, simple games, 3D games on your own. I'm assuming you have no background in using the tool. We're going to try to take you from there to having built a simple car driving game. I want to point out that even though the focus of today's tutorial is a car driving game, a lot of the same camera techniques, code hookup methods, and general navigation of the Unity tool will really map to any game in any genre, whether you're doing an action game, a platformer, a flight simulator, whatever it might be, even a puzzle game. So to begin with, let's show you the end result. That's probably a good place to start. And for that, I'm going to go to hobbygamedev.com/unity/simplecar. And you can see here we have a little car that drives around the environment, bumps off the hills. If it goes off the edge, respawns in the middle. And it's got a few extra features on here, so if I flip the car, I can press a button to reorient it. And also there's different cameras supported, so I have an example of a third-person camera, I have an example of a fixed camera location that follows the car, as well as a first-person view, just over the headlights, and an isometric camera, in case that's the style of game that you're interested in making. When you collide with a tree, it respawns the car back in the middle of the world. Okay, so let's see how this was put together. We've gone to unity3d.com, it's Unity's official website, and downloaded the tool. It is free to use, and if you want to pay more, there are additional features you could get, but the free version really is covering all that we'll need for the types of games that we're making. So with it downloaded, you will open Unity, and we'll need to create a new project. So let's go to File, New Project, and we're going to replace the words New Project here with Simple Car HGD. I just put HGD there for Hobby Game Dev. You can name, of course, the project anything that you would like. We don't need any of these import packages, but if we want to do special things, we could include those. So go to Create Project. So we have a new empty scene, and we need to get our game started. I want to encourage you, if you're not already, to be using a 2-button mouse. If you have a 2-button mouse, plug it in. It is very, very useful on a Mac. Don't try to do it with a 1-button trackpad. Using Unity in general with a trackpad is just not going to go as well. You're not going to have a good time. So the first thing we need to do is let's build a car out of primitives. And so we're going to go to Game Object, Create Other, Cube. Let's cover a few basic camera navigation notes. If you hold down the middle mouse button, the mouse wheel, and drag, you can pan. If you hold down Alt and left click and drag, you can orbit. To zoom in and out, I use the mouse wheel. And perhaps most importantly, if you're ever disoriented in space and you have an object selected, you can press F and while the mouse is over the viewport, and it'll center the view on the object. And so if I'm way over here and I'm kind of lost, under my hierarchy I can see here's the cube that I made. I can double click it and it will zoom. Or if it's already selected, mouse over the viewport, press F key, and it will zoom in on it and focus on it for me. So now to build this cube into a car, scale-wise, let's make this twice as long and half as tall. And you see I'm just typing these in here on the scale values on the side under Transform. And so that'll be kind of the body of the car. I duplicated it by clicking on it in the hierarchy, and then I use Command D, it's Control D for you Windows users, or you can go to Edit Duplicate. So now I have a second one. I'm going to drag that up. I'm going to make this into the top of the car. Let's make this not as long. One. Create Other. I'm going to use a cylinder for the tires on the car. Now to rotate, we could use this gizmo to rotate it by hand, and there's even a way to rotate with snap. But instead, because I want it exactly 90 degrees, I'm just going to type in 90. Apparently I want to rotate around the z-axis. I'm just trying them out and seeing, okay, that got me the direction I want for wheels. Let's make it a bit smaller. See where this puts us. 1, 0.3, maybe a little bit bigger, 0.5s. Make it not as wide. There we go. And I'm going to position these little tires in the front of the car. I'm going to duplicate it. Duplicate. And if you click and drag on these arrow handles, you can move it along just that axis, which is a good way to make things that line up. So there. So I have a simple car made. It's my car shape. And we now need to make all these under a single object. This will make it easier to manipulate the car as a whole piece. And so the way that we go about creating kind of a folder concept in Unity is to create a empty game object. Game object, create empty, here in the menu. And this will be our parent for the car, so let's rename this to car all. And then we click and drag each of these pieces we just made into car all. And so now, in addition to manipulating each of these parts, we can move, select and move around car all if we'd like to move it all as one piece. Let's make the ground. Going to make a new cube for that. Game object, create other cube. Let's move it below the car because we want the ground below the car. For scale, give me anything you want. I'm going to make mine 20 by 1 by 20. Again, you see here I'm just typing in scale values. You can see it's down there. So when we hit play, we have kind of a weird view of the scene, right? We've got this silhouette, and we can't really, you and I know it's a car because we placed it there, but it could use some lighting. And so to solve that problem, we're going to add a light, game object, create other. Directional light is what we're going to use here, just because with a point light, with a spotlight, or an area light, we need a number of them to properly light a scene. Directional light works kind of like sunlight, where we can just have one, and that will light everything. Let's move it away from the car. Its position in space actually doesn't matter, just its orientation. And so you can see I use those arrows to drag it away from the car. Remember, if I mouse over the viewport and press F, it'll focus on it. Mouse wheel zoom in to see what I'm doing. I'm going to use the rotation widget up here to affect how it's angled until I get kind of a good diagonal to show the lines on everything as best I can. And that'll do. And so now when I press play, you can see from the light, okay, we have a little better view of a car shape there. But our camera view still wasn't very good for looking at the car. So what we're going to do now is click on the car, mouse over viewport, press F, zoom back out, and kind of, since we know how to move the viewport easily, position the viewport like you would like your gameplay camera to be. And so I'm going to position kind of here in the corner looking down. Then we're going to click on main camera and go to game object, align with view. And what this does is it takes our viewport and sets up the main camera to match its position and orientation. So now when we press play, we see that our camera here has the same sort of view that we expected based on where we set up our viewport. You will notice, by the way, that whenever I press play, mine turns a hideous green. Yours probably isn't. Yours probably turns a shade of gray. This is actually a pretty important thing to know about. I'm going to show you how to set that up. And the reason why I make mine ugly green, I encourage some people to make it pink or blue or whatever you need, is that while you're in this mode, you can still modify values in the editor. And the risk is that while you're doing this, this is like for testing, if you want to move a character into the room or out of the room or move a wall, whatever, these changes get lost. And it's even more confusing if you press pause, because then you're back in your normal editor and you can still make changes, anything you want to do. But as soon as you press play to go back into editing, you lose all those changes that you made while you were in play mode. And so it's important to be able to tell very easily whether or not you're in play mode so you don't make changes and then lose them. So to do that, we're going to go to Unity Preferences. This will be in a slightly different location in Windows, but you can find it. And then in your preferences, play mode tint is what you want to change. By default, it's just a different shade of gray. I don't think it's a severe enough difference. Choose something ugly and eye-catching so it'll be very obvious to you when you're in play mode. Okay, so we have a directional light, we have our camera positioned, we have our play mode tint changed. Let's see, we've got our car under a parent. And so now let's make our car have some gravity. And to do that, we're going to select Car All. We're going to go to Component, Physics, Rigid Body. And this will add rigid body here under the inspector for car all under our hierarchy. And you see use gravity is checked, and so when we press play, we'll see the car drop a little bit and snap down. It's pretty quick. Just as a test, let's take our ground cube, which by the way, instead of calling it cube, let's rename this in the inspector. Select it in hierarchy, and now I'm going to rename cube to ground. Now let's rotate the ground. Give it an angle, just so we can see when we press play that gravity is in fact working for our car. Okay, it was a little better view. If I turn it up steeper, press play. Yeah, there we go. Okay, so gravity clearly is working for our automobile. I'm going to set its rotation here back to 0 to flatten out the ground. Let's give the car some headlights. Since we placed a directional light for the scene, we want to give the car spotlights. So first let's zoom in on our car, click on the car's body and press F. Going to go to Game Object, create other spotlight. So a point light is like a round light that emits in all directions. A spotlight is directional, which is what we want for the car's headlight. And you can see initially it starts pointing down, and I'm using the rotate gizmo, this one right here. W, E, and R switch between these, by the way, which is very handy to know. W to move, E to rotate, R to scale. And again, I'm rotating on the circle to get better control over the exact angle. And I can see here that roughly what I want is this thing close to 0, and these other numbers work out so the headlight points ahead. And I'm going to move it using the translation gizmo W, this one right here, kind of about to the position of where a headlight should be. I'm going to move the spotlight inside car all so that it will move when the car does. I'm going to duplicate it and move one to the opposite side of the car. And now when I press play, headlights here in front of the car. And maybe make that more apparent if I'll select both headlights, use the rotation gizmo and point them down a little bit more. And now it'll be much more apparent when I press play. Boom, there's the car's headlights. Now currently the ground is the same shade as everything else, which is kind of making it difficult to see the car. Let's create a new material. And so for that we're going to go to Assets, Create Material. It wants us to name it. We'll name it Grass. And if you ever need to rename something, you rename it the same way you do in your operating system. So on Mac, that means click on it and then wait. Or you can alternatively press Enter and then rename it. If you're on Windows, I believe F2 will do the trick. And all we're going to change for the grass is to set its main color by clicking on this white box. Let's just make it kind of a grassy green. And now we need to assign this material from our project onto the ground. And we can actually drag it directly here onto any object we want to assign it to. We'll assign it here to the ground. And when we click on ground, now we'll see the material appears under here. It is worth pointing out that this material is a shared resource, so if we assigned grass to more than one object and we change it for any of them, it will change the grass color or material properties for all objects. Now the next thing we're going to do is we want to make the car drivable. Let's go to Assets, Create C# script. I do want to say that JavaScript, Boo script, and C# script can all be used to do entirely the exact same things. I encourage C# script, if nothing else, because in C# it's a little better at keeping you accidentally making capitalization error, which JavaScript would invent as a new variable. Instead of new behavior script, let's name this a car driver. Okay. Now the first thing we're going to do is going to assign car driver script to car all. So we haven't even written the car driver script yet, but we want to assign it so that we don't write the script and then think it's broken because it's not working. So to do that, I'm going to drag it from project here onto hierarchy on top of car all. And under the inspector, you'll see my bar here got longer. We see the car driver script here when car all is selected in the hierarchy. So let's double click on the car driver script to open it in MonoDevelop. And you can see from the default comments and default functions that start gets called, owner of the script comes into creation, and update is called every frame. Let's add this code into the update function. If input.getKey keycode.w, then transform.position plus equals transform.forward times 5.0f times time.delta time. So this looks kind of complicated. You get used to some of this. It's not really as much of a mess as it seems. The if statement is checking that if the key button W is held down this frame, and this will fire every frame that the key is held down, then it will add to the current position the forward vector from the direction our vehicle is facing. So if our vehicle is turned, this will still make it move the direction the headlights are facing in. Times 5 is just sort of the way we're setting the speed for now, just so it's more noticeable. We'll make this number changeable here in a minute. And time delta time is necessary because the update function gets called every frame, and depending on a machine's system specs, the frame rate may be much higher or much lower. And by multiplying by the amount of time that passes between frames like this, we get a consistent speed independent of frame rate. So we're going to save the script, Control S or Command S, depending on your OS. And let's try it. Press play. And now when I press W, I can see my car is going backwards. I seem to have misunderstood the headlights. And I should have known this. As you'll see here, the Z-axis is pointing this direction. If you hold down Shift, you can select more than one thing at a time, or I think Control or Alt or Command or something. Okay, we're going to rotate the headlights back in front. There we go. And now when I press play, sure enough, W drives my car forward. Let's make it so we can turn the car. We'll just write a new if statement. If input.getKey keycode.a, then here we're going to do transform.rotate 0.0f negative 80.0f times time.delta time 0.0f semicolon. Something else I'd like to point out is that transform is implied to be the position, rotation, and scale data of the object that we've assigned the script to. So if we had a reference to some other game object, we could do that reference dot transform and get the position, rotation, and scale of that object. If we don't specify a game object, then it's assumed again to be the one that we assigned the script to, or in this case, car_all. We're going to copy and paste the turn code over to the D key and remove the negative. And what this is doing is it's calling a rotate function. Remember, so transform keeps track of rotation, and rotate, there's many ways we can call the rotate function. The one I'm using here, we give it the angles to turn along each axis. So we want to rotate 0 along the x-axis, 80 degrees to the left in this case with a negative, in the y-axis, which is the one that goes up and down through us, again times delta time to accommodate for variable frame rate, and 0.0f along the z-axis because we don't want to roll. If we test this now, we'll save the script, press play, and your car should now rotate and drive. There's no reverse yet, we can add that in a moment. And you can, of course, you can drive it off the edge of the world if you so please. Let's go ahead and add reverse. This will be a very simple change. We're going to duplicate the code that we have for moving forward, assign it to the S key, and we'll subtract instead of add that movement amount. And let's actually change this number also to 2 so that we will move backwards slower than we can move forward, as cars tend to do. I will say that there is a more robust way to handle input that allows the user to remap the key codes. So you could also use the arrows or use a joystick or a gamepad. That won't be covered here, but I will show that example of that in the final source code that will be provided at the end. And so again, let's save that, press play, and we can now drive the car around, including reverse, and take them off the edge of the world. You might be wondering, how do I know those things that I'm doing inside the script? How do I know that those exist? Unity actually has a great script reference, unity3d.com/support/documentation/script reference index.html, and you'll see a link to that on the site. But this provides all kinds of helpful information about what you can and can't do in script, and as well as examples that you can switch to C# or JavaScript. We just have these numbers floating around, 5 and 2 and -80. What we're going to do is we're going to make the speed modifiable for our car. Here inside of our class for car driver, in the car driver script, I'm going to add public float forward speed equals 5.0f. I'm going to make 3 variables. Backward speed equals 2.0f, and turn rate will equal 80. So we have 3 public float variables. These f's after the 0 are to show the computer that this is a float as opposed to a double precision value. And down here we're going to replace these numbers we had with the variables, forward speed and backward speed. I'm auto-completing, by the way, by pressing enter when it suggests what it was that I was typing. Turn rate and turn rate. Okay, and so all we've done is we've made 3 public variables and replaced where they were in the code down here, saved the script, and now if you click on Carl in the editor and scroll down in the inspector, you'll see that here these numbers are exposed: forward speed, backward speed, and turn rate, and it inferred those names based on how I camel cased these variable names. See, I called it turn rate with a capital R, so it knew that turn rate was the word. And we can change these numbers here. So if we make the car drive forward much faster, we can change that 5 to 20. And vroom, now it's so much faster than it was previously. If we want to make it move much slower, change that number, and it goes down to a crawl. And so of course this is a really powerful way to make it so you can create an object and then change it inside the editor on a per case basis. Or for example, if a programmer on your team wants to set up something without worrying about tuning, and then have a designer on the team worry about how to get the project's pieces all moving and behaving in a fair and sort of usable manner. It's an advanced and sort of future hint that we are manipulating this car's position directly by changing its transform position. Because it has a rigid body, another way that we could move the object is to apply physical forces to it, and that works a bit differently. Instead of update, we would use the function fixed update, and instead of transform position for our code, we would instead do something that looks like rigid body.add force vector transform.forward, and this would apply a forward force to the car of a certain magnitude. This is a certain type of gameplay that it leads to. I find it sluggish, of course, but for games that are physics based, it's important to use forces to move things around for collision reasons. Also note that I did this in fixed update. The difference between fixed update and update is that fixed update is called a known number of times every second, unlike update, which is frame rate dependent. And so it's important to use fixed update for any code that does physical manipulation to the rigid body for a vehicle or an object. We were able to use rigid body there. It's just like transform, is it implies that it's the rigid body assigned to the game object the script is for. Now let's add a sphere to make hills. Going to go to game object, create other sphere. We have a sphere here. Let's make it let's change its size a bit. I'm going to do 0.74 to make a short flat hill. Move it down so it's halfway underground, using the F key and mouse wheel and stuff to get a close-up view of doing this. Okay, and for now let's just leave it white. Try driving over it, and you will initially encounter that it is going to flip your car. It's very, very oddly tall for how big it looks. And see, the reason for that is because by default a sphere uses spherical collision, which is why we see this big sphere around it. That's what the car is hitting, because it's a faster calculation that can do collisions based purely on distance. What we really want here, component physics mesh collider, Again, this is with the sphere, the hill selected. I'm going to go to Component Physics Mesh Collider. Tell it to replace because it's saying you already have a sphere collider here. And now it will use the mesh data, the polygons of our shape, instead of assuming it's a sphere for collision. And so now we have a much more modest bump for the car to ride over, and a lot more sort of smooth driving experience over the top of it. While we're here, let's go and assign grass to the hill so it blends in a bit better. Let's create a better system for our camera. One way to do this is sort of a very easy, I might say lazy way to do it. If we just click on the vehicle and move our camera, move our viewport around to where we'd like it to be for a third-person camera, and then we click on main camera and do the same trick from earlier. Our game object align with view. That'll put the camera where our view is. And remember, it'll stay there. But if we make it a child of car all, then it will move along as the car does. And we now have sort of a third-person camera. But this results in an extremely rigid camera, which isn't very nice. It's not very smooth. We don't have as much control over sort of making it lag behind the car or any effects like that. So let's move the camera back out of car all, and let's instead control the camera with a script. We'll go to Assets, Create, C# script, and we'll call this car cam. Okay, now selecting car cam, going to that script in mono. We are going to create a few new variables. Public camera, use camera, public transform, track object, and then inside the update function we're going to tell use camera dot transform to look at track object. And now the way this is being set up, we can specify any camera to track any object, and it will constantly point itself at that object. We could have the object assume that what we've assigned it to is the camera or is the object to be tracked. Instead, we've written this in such a way you can swap them out. Partly is to show how to make those connections inside the editor through various ways. And this will also, by centralizing it in this fashion, make it easier for us to change the ways that camera can be switched between if we want to have multiple camera modes supported. So let's go back to the editor.